guys, it's Rita. Today we're going to be doing lesson 2.1, but we have a special guest.
Hi, I'm Lyric. I'll be helping with today's lesson.
Yay!
We're going to be doing notes over change in arithmetic and geometric sequences. A sequence is an ordered list of numbers. It could be finite or infinite. Each listed number is a term. So here, 1 is our first term, 2 is our second term, 4 is our third term, and 8 is our fourth term. And each term after that is considered the nth term because each number is considered n. The graph of a sequence contains discrete points, not a connected line or curve. As you see here, each point is not connected by anything. If each successive term in a sequence has a common difference or a constant rate of change, like when you have a linear function, the sequence is called arithmetic. The nth term of an arithmetic sequence is given by a of n equals a0 plus dn. a0 is our initial value or our zero term, and d is the common difference. So find an equation that represents the sequence 2, 5, 8, 11, and so on. Using your equation, find the 100th term of the sequence. So if we go 2 to 5, that's plus 3, 5 to 8 is plus 3, 8 to 11 is plus 3, so our common difference is plus 3. So d equals 3. And to find our 0th term, we go back from 2, which is our first term, and we'll get negative 1. So using our equation, we'll get a100 equals negative 1 plus 3 times 100, which will give us 299. And you can write the equation for the sequence in any term, not just the initial term. So an equals ak plus d times n minus k, where ak is the kth term of the sequence. Okay, here we have our kth term, k equals 1. So we're going to look at our first term because k represents the term in the sequence. Our first term is 2, so using our formula, we'll have 2 plus 3, which is our difference, times n minus 1. Then, when k is equal to 2, that's the second term in the sequence, which is going to be 5. So, using our equation once again, the second term is 5. 5 plus the difference of 3 times n minus 2. Once again, with k equals 3, you go to your third term, which is 8. Using your equation, 8 plus 3, the difference, times n minus the third term. Then finally, k equals 4. We go to our fourth term, which is 11. A of n equals 11, our fourth term, plus 3, our difference, times n minus 4. Here, subtraction is still arithmetic. It's just adding a negative number. So if we have the sequence 7 to negative 3, negative 8, it is decreasing by negative 5 each time. So our first term is 7. K equals 1, which is 7. 7 minus 5, because we're decreasing. And negative 5 is our common difference, times n minus 1. For geometric sequence, if each successive term in a sequence has a common ratio or a constant proportional change, the sequence is called geometric. The nth term of a geometric sequence is given by g of n equals g of 0 r to the power of n, where g0 is the initial or zero term and r is a common ratio. So if you see here at our graph, there's like a curve that it follows. If you go to the arithmetic graph, it is a straight line because it's linear. There's a constant rate of change. So find an equation that represents the sequence 2, 6, 18, 54. If you look, our common ratio is times 3. So to go to our 0th term, you're going to do 2 divided by 3, which is 2/3. So g0 equals 2/3. When plugging that into our equation, gn equals 2/3 times our common ratio, which is 3 to the n power. You can also write an equation for a sequence using any term, not just the initial term, and that's when we'll use our equation g of n equals g of k times r to the power of n minus k. G of k is the kth term in the sequence, like above with the arithmetic. So if we want to write for the sequence 2, 6, 18, 54, we know that the common difference is 3, or common ratio is 3, as we found above. So g of n equals 2 times 3 to the n minus 1. 1 is our first term in the sequence 2, which is why 2 will come to the front and represent g of k. And the common ratio is 3, so 3 is r. getting the equation 2 times 3 to the power of n minus 1. If we're finding it for the fourth term in the sequence, g of n equals 54 times 3, n minus 4. 54 is our fourth term, putting it in the spot of g of k, times our ratio of 3 to the power of n minus our fourth term, which is 4. Okay, continuing, division is still geometric. It's just multiplying by a fraction between 0 and 1. So if we're going from 64 to 16, 16 to 4, and 4 to 1, we are dividing by 4 each time, or multiplying by 1/4. So using our equation, g of n equals 64 times 1/4 n minus 1. 64 is our first term, which is why we got n minus 1. And the common ratio is 1/4. Okay, now for some practice. Our first equation, we have the sequence 9, 27, 81, 243. Looking at this, I know that 9 times 3 will give me 27. To get from 27 to 81, it will also be times 3. To get from 81 to 243, it is also going to be times 3. So I know that this is going to be a geometric sequence because there's a common ratio. So the equation for that is g of n equals g0 times the ratio to the power of n. So to find our 0th term, we're going to take 9 and divide it by 3. So 9 divided by 3 is going to give us 3 as our 0th term. We also know our ratio, r equals 3, because we're multiplying by 3 each time. So our equation, when we plug everything in, g of n will equal 3 times 3 to the power of n. And now for number 2, we see that we have an arithmetic sequence as we go up plus 3 each time. So going back to our formula, we have a of n equals their initial term, or our 0th term, plus the common difference times the nth term. So going back down, we will have our common difference is 3, so d will equal 3. And to find our 0th term, we have to go back from -4. So -4 minus 3 will give us -7. So now we have our two most important pieces of information. We plug those in. A of n equals -7 plus 3n. Okay, now we'll be finding an equation that gives us the nth term of each sequence. Instead of the initial value, use the kth term of the sequence in your equation. K is given for each problem. So for number 7, we have k equals 2, which is going to be our second term, which is 15. And we're dividing by 5 each time. And another way to say dividing by 5 is multiplying by 1/5. So when we go find our equation, we have g of n equals gk times our common ratio to the power of n minus k. Going back down, we know that r equals 1/5, and we want to find our second term, which is 15. So plugging those in, we get gn equals 15 times our ratio, which is 1/5, to the power of n minus 2. Continuing on to number 8, if we look, 44 to 36 is -8. 36 to 28 is also -8. 28 to 20 is -8. So that we know our common difference is -8. So we can go ahead and write common difference is equals -8. And we're starting with our fourth term because k equals 4. Our fourth term is 20. So g of k equals 20. And we know that it's arithmetic because it's a common difference, not a common ratio. Going up, we see our equation ak plus d times n minus k. We're going to use that formula to plug what we know in. So we have an equals 20 minus 8, because we are going down by the common difference of -8, times n minus 4. 20 is our fourth term. So here we'll be finding the nth term of each sequence. So for number 13, we're looking for the 87th term. So we know that n equals 87. But before we get there, we know that we are going down by 10 each time. So 105 to 95 is negative 10. 95 to 85 is also negative 10. 85 to 75 is negative 10 once again. So we know that our common difference is going to be negative 10. So using those, we know that our first term is 105. A1 equals 105. So we're going to plug those into our equation from earlier. We have AN equals 105 minus 10, which is our common difference, times n minus 1. But we're finding the 87th term, so we're going to plug in 87 for n. So rewriting this, we will get A of 87 equals 105 minus 10 times 87 minus 1. When we solve, we will get negative 755. We are going to continue on to number 15. So we are looking and we see that we are increasing by 6 each time. So plus 6, and plus 6. Our difference, common difference, is going to be 6, positive 6. We know that A1 equals 86. That's our first term, negative 86. And we are trying to find the 52nd term. So we know n equals 52. Following what we did above, we're going to start with our equation for the sequence. So an equals negative 86, our first term, plus 6 times n minus 1. And we know that n is 52, so we can also write this as a of 52 equals negative 86 plus 6 times 51, because 52 minus 1 is 51, which is going to give us the answer of 220. Continuing now with more of a challenge problem, we're going to find which equation can represent the sequence 1/2 to 832. Looking here, we know that 1/2 to 2 is times 4. 2 to 8 is also times 4. And 8 to 32 is times 4 once again. So our common ratio is going to be 4. So this is a geometric sequence, considering that our first term is 1/2. G1 equals 1/2. Or we could think about our initial term, or the 0th term. So we will divide 1/2 by 4. 1/2 divided by 4, or multiplied by 1/2, or multiplied by 1/4 is going to give us 1/8. So knowing that, we know that our 0th term, G0, equals 1/8. So we know this one's out because we do not have 8 anywhere. We know this one will not work because our common ratio is not 1/4, it is 4. We know that number 4 is out because our second term is 2. However, our common ratio is not 1/4. So that leaves us with 2 and 5. Looking at 2, our first term is 1/2 and our common ratio is 4. So we know this is correct. Looking at 5, we are starting with our 0th term, and our 0th term is 1/8. And we know that our common ratio is 4, so these are both correct. Thank you so much for watching this video. I hope these were helpful, and good luck on your test.